All right, so now that we're doing what I consider to be the 102, I figure at this point we basically understand the basic language,
Yep.
and now we want to start applying it and start making it do stuff for us. And so what I'm going to do right away is I'm just going to start sharing my NetBeans environment here. If it'd make more sense if I share my desktop, and then I got to do the infinity thing. Okay, so you remember where we were at? We ran this kind of application, this thing where we did drew some animation, some blocks, did some collision detection, right?
Yep.
You see that where it decided to detect the collision, and we also decided that we wanted to maybe do something cool for the 102 project, so some kind of programming thing. So
Yeah.
what I want to do is let's see. That's what I think the best thing to do is to kind of revisit this code. Just make sure that we're still on board. Now, everything that you see there is actually contained
Okay, I can't.
in.
I'm sorry, I can't actually see anything on your screen. It's just black.
It is?
Yeah. I don't know what's wrong. There's just this like black line across my screen.
That's kind of crazy. Let me do a stop sharing and reshare. Maybe it's all. Maybe if I share just the application. I think if I do that though, you're not gonna be able to see if I run something.
Yeah.
So let me try resharing then. Okay, do you see it now?
Yes, I see that.
Okay, so maybe I just had to stop and then restart it. But you do see it now.
Yes, I do.
Okay, good. Let me make sure. So I am okay. I got the infinity thing going on. So what I wanted to do was to relook at this code line by line to make sure that we get it kind of. Since we had the break, you might have forgotten a couple things. How was your holiday?
It was really good. What about you?
Oh, it was horrible. But that's okay. We got past it. Yeah, we had a little bit of car troubles on the trip, and then we had the one thing led to the other. But yeah, they can't all be good. Somebody's gonna have a bad time.
Yeah, I suppose so.
Yeah, I guess so. It just wouldn't be very equitable if everybody had a good time. Then what would be considered to be good, right?
Yeah, what do we
Yeah,
base it off of?
yeah. What are you based on? Somebody's gonna have a bad time. So okay, so let's see. So if it's pretty amazing if you think about what we just did here. A lot of these lines are really not that interesting. Do you see how that curly brace takes up a whole line by itself?
Yeah.
Okay, we have 87 potentially lines of code, which most of it really is not code, and it's doing that thing that you saw. Now that's pretty darn cool. Because a lot of this is really not that heavy. It's not that interesting. You know what I'm saying?
Yeah.
So let's take a look and see. Make sure we go back through the code and look at this step by step and see what the code is doing and get kind of caught back up, if you will. So we
Okay.
made a class called animation here. Remember, a class is you're defining your own type. This is a special kind of class in the sense that it contains the main. And if you remember properly, this is the place that the main entry point. So when Java first starts, it plops into here and says, what do I do? And
Yeah.
this tells you what to do. Okay. So what this does is what it does here is it actually instantiates itself as a class. If these two lines were not here, this application would not do anything. You understand that? Because it would
Yeah.
get in here, there's nothing to do. It would get to this point and be out. There's no direction. But in this case, what it's doing is it's making a copy of itself, basically of every line in here. And since it has a remote control to it, it says, now I want you to specifically call the play method. And this is where play is defined, is right here. When it also does the constructor, this right here, it also runs the constructor. Now, in this case, it does not have a constructor, I don't think. You look on down. No, it does not have a constructor. But if it did have a constructor, it would look something like this. Public void animation would look like this. Remember that?
Yeah.
Now, the reason this makes this a constructor is because it's a method with the same name as a class.
Okay.
That's the thing that makes that special. When when you have a method the same name as a class that is its constructor. Now, it turns out that you can have multiple constructors. You can have a constructor like this. You can have another one right down below it, except this one might be special where it takes like an int value of some kind. Okay. And then you can say, I don't know, x1 equals value. Now, see, in this case, this has actually got two constructors, but they are different. And if you call the constructor with a value, it will call this one. And if you do it with no value, it's going to run this one. So this one right here is going to run this one. Right now, basically, it's not doing anything. Okay. However, if I were to put that like the number 12 in here, then it would run this one.
Okay, because it actually has a value.
Now, I'm wondering why this is complaining. Wait a second. Why is this really a problem? Animation in class animation cannot be applied to given types. Required no arguments. It found an int. What is its problem here? You cannot do operator overloading in Java, or what's the deal? That is very interesting to me right now, so I'm going to search for something. So when I run across something that I don't quite, doesn't quite work the way I want, the first thing I do is I'll research it, like I should suspect you would here. Say Java constructors with parameters. Really don't even know what to search for here. Oh, I have a return value on it. I bet you it doesn't like that. It probably doesn't like a return. Let's see if that's all it is. That was it. So it turns out that constructors, since it's it cannot have a return value for constructors. Okay.
Yeah.
Okay, so I put the word void there, but you're actually not even supposed to say that by the syntax. Normally,
okay, so with a constructor, you just do public and then the class name.
Yeah, and then the parameters. Now, this one has two different kind of constructors, and of course, if I call it with a value, then I'm initiating this constructor, and if I do it without a value, I'm done. But in neither case here, am I actually wanting to define a constructor? I'm just was kind of reintroducing you to constructors and their usage. Because when you call the constructor, this would have done something if we had a reason to call a constructor, and the reason you want to sometimes is to initialize certain values and stuff. But it also these values right here, which are defined inside the class but not inside the thing, they also get executed too.
Okay.
So actually, and they're visible. These are member variables to the class animation. Okay. And the purpose of x1 and y1 is to be the x and y coordinate for rectangle 1, and x2, y2 is the coordinate, the x and y coordinate for rectangle 2.
Okay, so
now,
this is the x1 and y1 is for the interface of like the game, not like something in the game, right? It's the application itself.
It's actually keeping track of the xy coordinate of the box.
Like, okay, yeah. Okay, so
because there's only two rectangles. Yeah, there's two rectangles in here, and so what we do is this is like the initial location of box x, x1 and y1, and the initial location of x2, y2.
Okay.
Okay, it's just a place for it to start. I mean, if we were to put different numbers, then it would start different numbers. But let's go ahead and look here. We're actually creating a constructor, which what it does is it initializes these variables here. And then we say play, and this is basically the init or the Kickstarter or whatever you want to call this, okay?
Okay.
Now, it turns out that we're deciding to do this inside, we're not doing this on the console, right? The console was basically you know what the console is?
No.
Okay, you know what a DOS prompt is?
I do not know what that is either.
Okay, so let's go over here. Back in the old days before Windows, there was this Can you see my little command prompt here?
Yeah.
Okay. Really, this is basically like access to the operating system, but no graphical environment. And I can type in commands like dir for directory, and then I can say cd. Oh, there's a command videos. I can go into videos. Dir, I can get a listing again. You can run applications and things like that. But anything that kind of prints out to this shell or this environment is considered to be a console application. Then when we did all the advancement of having graphical stuff, then you have applications that run as GUIs or graphical user interfaces, okay?
Okay.
So when we were doing the console, where was that out example? Oh, we commented out right here, systemout.println. This was actually printing this information to the console, which was down here in the output.
Okay.
And this little output window right here was basically a GUI version of what would be printed out on the actual on the console. Basically, it's just like raw text to an environment that can't do any graphics. Okay.
Okay.
But this application is actually going to be graphical, and that's why it starts out with a JFrame. And a JFrame is a Java frame, and that's basically trying to define an area, a graphical area where you could plop stuff onto.
Okay, so it's like the app itself.
Yeah, it's the app itself, or it's a frame. It's just like a picture frame, and says, okay, give me a new picture frame, and now inside this picture frame, you can do different things that you could not do in the console.
Okay.
Console does not do any kind of graphical thing. It's all text, literally. It's just text. There's no graphic ability in it. So a Java frame is a different kind. It's just basically an area where you can do graphics and GUI-like operations, and then you get a handle to it, and you can do things with it.
Yeah.
Okay. Now, one thing that this sample does is what it does is sets the default close operation so that when you click on it, it closes on exit. Now, I'm pretty sure I wanted to look at this before, but we didn't want to do it then. If I comment this out, I bet that's the default behavior anyways. I wanted to verify that. Yeah, because I think what that does, I'm pretty sure what that did was basically say when I clicked in the top right hand corner on the X, it actually closed the application. I'm pretty sure that's the default behavior anyways.
Okay. So we're basically just setting the default to the default.
I guess so. You'd have to look in the we'd have to look in the documentation here. Oh, that was the other thing too, is if I can, let me see, Java doc here. Let's look up the Java doc on that frame. Oh, looks like my Firefox is going to install some updates. And here's the method, right? Here's the method that we want information to. Guess what class it's going to be part of?
The default class?
No. So this is a method, right?
Oh, yeah.
What class is this part of?
Animation, right?
No, that's part of animation. Did animation define this method?
No.
What defined where is this method defined in what class?
Well, isn't there only one class?
No, there's lots of classes. For example, no, there's a lot of classes. Like for example, on this system.out, that's an object. Println is a method. No, there's lots of them. So look at how this is related. I'm going to highlight that again. Look at how it's related. What is this method related to?
It's related to the JFrame.
It is.
So...
And it's actually going to be the JFrame object or the class or object, same word, that's going to define this method. Okay. You see how we said use this object, this method, or this object or this class. Make me my own personal copy in it, and I'm going to rename it to my own personal name, and just make a new instance of it, and now I can make references to it. Do you see how it's definitely related as a JFrame method? You see?
Yeah, that makes sense.
Okay, now, so if I go back to this question I initially talked to you about, where's my? Oh, here it is. So if my initial question was, here's the method. If I go up, what class am I going to find this is associated with?
The J-frame.
The J-frame, that's right. Watch it if I go all the way to the top here. It's going to be no surprise that this document, all this documentation right here is going to be about this, see, J-frame.
Yeah.
No surprise. Okay. But the J-frame can do all kinds of cool things. And one of the things that it can do is the thing that we're using it for. But we pulled it off of an example. And so I wanted to make sure that I now spend some time with you to find out exactly what this is doing, and let's see what its options are. See if we're even using this correctly, right? I'm gonna go down and I'm gonna find, oops, I thought that was searching the page, but it's not. Control F, B, and then, oh, here we go. This is it. Okay, so it says, basically, it obviously sets the default close operation. It says the operation that will happen by default when the user initiates a close on this frame. Okay?
Yeah.
Now, there's probably lots of ways to issue a close on the frame, but probably the very most common one is to click the X in the top right-hand corner, and that initiates a close. Watch this. Let's change this just for the fun. Now, if we say, here's one of the possible values of it, don't do nothing on close. And now let's bring our application back up and change it to that.
Okay, so then it won't do anything when we press the X.
Why is there a, I'm wondering why there is a error, or why I can't run. Why is it done? Oh, I want to know why I can't run the file. There's run. Why is my little run button thing not available? Animation run. That is right.
Huh.
Huh. Yeah, I don't know. But I'm going to do this, and I'm going to do where's the build thing at? This is not looking right. But anyways, I'm going to say build. I don't know why this is acting funny. I'm going to close this. It looks like there's a whole like stuff running in the background or something. Close, close, close. Okay. Okay, let me reopen that thing because it was not helping me like I thought it should. Okay, here we go. Animation again. Source package, the animation, and there. Here we go. So you got the little play button now again.
There we go.
Okay, so then if I say this, do nothing on close, and I hit this, watch, just see how that changes the behavior. I think I know what to expect. So I slide this over here and I click on the X.
Nothing happens?
Nothing happens. That's pretty crazy, huh?
So could we do something to where like we have that same thing, but it says default operation expand on whatever the expand button is, and then it expands like to full screen?
Oh, like this?
Yeah, or is that default?
Well, you get some default behavior. If you want to change it, then, or not even necessarily change it, but if you wanted to, for example, oh, look at this, I'm really stuck. I don't think I can close this. Let me see. Oh, I have to actually go down here and click the stop button.
That's funny.
Okay? So I actually kind of locked myself out almost permanently on the thing. I can remember when I had my computer, it was a Commodore 64, and a lot of the system commands were issued through through a series of commands on the command line. It had a command line, by the way.
Yeah.
And the commands were called peek and poke. And peek was the reading operation, and poke was the writing operation. And everything was done through an address. So one thing I discovered was there was this one address that represented the keyboard. And I can't remember what it was. Well, let's see if we can find it real quick. Anyways, I thought it was so cool because I could say poke and do an address and then like the value 0. Hit it and the keyboard went dead.
Huh.
Let me see. Poke for the keyboard. Let me see if I can find it. I'll find it. Get the poke command for the keyboard. Oh. So these were the kind of commands. Oh. There it is right there.
There we go.
Poke 649,0. That's how you disable the keyboard.
Wait,
I thought it was so cool.
so once you disable the keyboard, are you just like stuck there?
Yeah, you're just stuck. You had to power cycle it.
Oh, that's funny.
Yeah, it is funny. Okay, but all this stuff was done on a command line. So, but you know what I'm saying is it doesn't hurt to experiment and play around. So you want to know. Okay, let me see. There's a hide on close. Oh, hiding on close. That would totally mess people up, right? You clicking on close and instead of closing, it hides.
Jeez.
Okay, automatically hide. So can you imagine now? So can you imagine you get to control every button and every operation and stuff, and all of a sudden you got this software that pops up that says, "Would you like to buy this? Would you like to buy this add-on to your game?" Is the no? Does it have to be no?
I mean,
the no could be yes.
Yeah.
Because you're as a developer, you have that level of control. There's nothing forcing that to be what it says it is.
So they click the X button and then they buy it.
And all of a sudden, yeah, it's just kind of rude.
Yeah.
You know, and then you have to say, well, I think you clicked yes, and they'll say, no, I think I guess I clicked no. But anyways, there's that level of control. Let me see. There's a feature like let me see. Oh, here it is. It's the impossible button. Oh, I don't know what this is. I didn't know. I didn't prepare for this. But have you ever seen the situation where you go to click a button and then the whole button moves, and no matter how you move the mouse, you can't get the button.
Like,
you know, like it moves on you. Like as soon as you get close to the button moves.
Oh, I've not seen one of those.
There's no way to click on it.
That's funny.
It's just kind of funny. It's like, you know, you ask some really historical question, like, you know, I don't know. Anyways, you got a lot of control, so sometimes it's nice to be able to read into the documentation to see what kind of cool stuff you can do.
Yeah.
So this is obviously what would be really nice is if they told you, do you see where it might define the default behavior? Let's see. Oh, look at this. Oh.
There we go.
The value is set to hide on close by default. So we actually said exit on close.
Oh. So when we took out that line of code to test it, to see if it was default, was it actually hiding and not closing?
Well, it says it automatically hides the frame after invoking any registered. I don't know what the difference between hide and exit is. Let's go back to the default behavior and see. Well, since we know that's default, then I'm just going to comment this out. I think to us as users, it kind of looks the same. Nope.
Wait, so did it hide or did it close?
I don't know, but look at that down. You see that one task running down here?
Yeah. So I guess it's just.
It never actually.
Huh.
Okay, you see animation run down here?
Yeah.
And it has running?
Yeah.
And and it goes like this, and I click on it.
It's still running.
And it's actually still running, and I actually have to click on stop to make it stop.
It's weird how the default is hide.
Well, yeah, and so really the default. So if you want this to act like you're kind of expecting with application, you got to look and change this behavior. Now I click like that, and it's done.
Yeah.
That's exactly why that was put in there. So now we learned that. Now, a frame is an area where you can draw or where you can put stuff. And one thing that you can put on the inside is a panel. So if you look at the method get contact pane right here, this method, and then there's also a method in this method. What method is this? What object, what class is this method associated with?
It's frame, right? Or is it panel?
Frame. No, it's frame. See that?
Okay,
See,
yeah.
frame dot. No trick there. So it's a J-frame. This is another J-frame method. This is also a J-frame method. This is also a J-frame method. So you got to ask the question, where's this draw thing at, right?
Yeah.
Well, it turns out that this J-frame method requires that you add a drawing panel inside the frame. This is how you add. So a frame is not an area where you can do anything in particular, but it's a kind of a layout area.
Yeah.
And there's a particular area that says, hey, I want to be able to do some drawing operations. So you cannot draw on a frame, but you can draw on a draw panel.
Yeah.
Okay. So let's take a look in difference here. Let's just, again, look at the documentation. And you go up here to find out what is a J-frame. So a J-frame, let me see. There's probably not an easy definition here for you, but basically it's a graphical window area, okay? And the drawing panel is something so you can draw. Let's see where we actually, and then we add the word draw, and then it basically, what it does is it allows you to, so, yeah, what it does is it will give you access to these drawing panel thing, will give you access to methods that will invoke the drawing. Okay.
Okay.
And
so
the
like
entry,
the colors and stuff?
Yeah, you get access to colors and shapes and rectangles and placements and all kinds of stuff like that. So, so this is basically saying put the draw panel inside the frame. Make the frame 500 by 500. That's a square size. You could change that, right?
Yeah.
This is 500. This is 500 by 500 for my monitor.
Okay.
It depends a lot on your resolution, right? You can make this 1,000 by 1,000 be twice as big. Then we got interesting that you have to say set visible.
So what happens if you don't set it as visible?
Well, it's going to do probably exactly what you think. You won't be able to see it. Yeah, it's running.
Yeah. Okay.
Look at this. It's running. See this down here? It's running.
Yeah. So it's just basically default is that it's not visible.
It's not visible. And yeah, you can have stuff run in the background and do all kinds of calculations and stuff because the user doesn't care about it. But it's not very interesting when you're trying to display a graphical element to them and you say visible equals false.
Yeah.
That just makes no sense. Okay. So if you remember each class, we only actually instantiated the animation class once. So there's only one copy of this running around. And it only has, and so inside this class, when it runs, it goes through this for each loop here. And what it does is it decrements the X and Y, which puts it at like a 45-degree angle. Do you get that? So if it goes over X, if it goes in X one direction, it also goes Y the same amount.
Okay.
And the same thing for this one. So one of them is approaching the other one because this one's gone minus minus.
Okay, so I forgot what does it mean when you have the minus minus or the plus plus?
Okay, this is exactly the same thing as X1 equals X1 minus 1.
Okay. And that's what the two minuses or two pluses mean?
Yeah. And this line means X2 equals X2 plus 1.
Okay.
It's just a shortcut syntax. Saying two pluses or two minuses after it instead of writing out the entire formula.
Yeah.
Because it's used so frequently in programming. So it's been made as a shortcut. It's a very, very common shortcut too. Take a look right here, especially in loops. I know I want to go one by one, right? So this is I equals I plus 1.
Yeah.
And I always want to increment by 1. So this little plus plus or minus minus thing is done quite frequently. And then what I do is basically I define the position of the square, the x and y coordinate, and I call repaint. Well, repaint on draw. Repaint on draw. See this draw here?
Yeah.
It's also called a constructor. It's also a draw panel. And the draw panel is what we have defined here. It extends a J panel.
Okay.
So it's the panels that you draw on and the frames that contain it.
Okay.
So J frame, and then you got a J panel. But this is a special type of, we're calling our panel draw panel. Okay, we could call it whatever we want. And then, and because it extends a J panel, then you get all of the functionality inside of it that a J panel is. And one of the things is paint component. This turns out to be the, anytime that it does a draw, it calls paint component.
Okay.
Okay. It's actually the main entry point to this constructor. So basically, many times you call repaint, it does a whole bunch of stuff, but eventually comes around here and also calls paint component as entry point. And so every time it says to paint, what we do is we draw a rectangle, and then we set colors, and we fill the rectangles with let's see here. This is the graphic element, so we set this. Oh, this is actually for the setting the background color of the entire screen, of the entire J panel.
Yeah.
And then we did our fancy little collision detection thing and changed the colors from blue to red, because if not, it does red, right? And then it fills the rectangle here and does the other one with green. And then every time it repaints, which is frequently. So what you have to think about here is this this only calls repaint every time it comes through the loop. So then the I increments another value, it changes the x and y positions, it does a repaint, and then it comes over here and does a new paint again. So a redraw.
Okay, so is the
repaint
repaint like
repaint comes clear too.
okay, but is repaint the thing where like when it collides it changed colors? So it like repainted
No,
itself?
that's collision detection.
Okay.
So this is just literally drawing the rectangle on the screen.
Okay, so
Now, because we keep changing the position of it, it looks like it's moving.
oh, I think I see, yeah.
So every time it runs through this for loop, because we keep changing the initial value to something else and we repaint it. You ever done with those little flip books, like on the side of a book, and you made a little
Yeah.
stick figure dance around?
So like whenever you flip all the pages it looks
Yeah.
like it's moving. Yeah.
Okay, this is the same technique here. What you're doing is basically you're drawing a rectangle, and as soon as you're done drawing it, you turn around and you say, I'm going to draw it in a different location, clear the screen, and draw the rectangle in a new spot. And you do that over and over and over, and it looks like what appears to be happening is that it is animated.
Okay, and we use repaint to control that movement.
Repaint clears the screen, and then it comes over here and calls paint control, and it draws these rectangles in a new spot defined by this new X and Y one, and this right here.
Okay. And then since it's plus plus, it moves up 1 or goes 1.
It moves, basically the value changes both X and Y. And this is exactly why it moves diagonally, because both X and Y are moving at the same time, see?
Yeah.
And so we decided that the 0, 0 coordinate was, what was it, top left-hand corner? I think that is right.
Yeah, I think it was.
Corner. So basically, when you increment X and Y, that's probably the green one here that's going down. So that's probably the other one. And the other one is subtracting, so it's getting closer and closer to 0, okay?
Yeah.
I guess if we let this go, it's actually literally going to draw it off the screen. Oh, that's kind of cool. So they eventually will leave the screen and go forever. There's no boundaries. So if we, but it only went to only, it stopped at 150. If it went on forever, then these babies would be off the page, okay?
Yep.
And it would be mathematically off the page. And it would still spend the time. Now, the reason it goes as slow as it does is because we specifically said wait a quarter of a second. If we want this
Okay.
animation to go faster, I just took a 0 off that thing and watch this thing move now. Okay?
Yeah. Huh.
The only reason it moves and draws as fast as it is because we put this delay factor in there.
Yeah.
That controls the speed of the operation. Okay, and now the other thing that we did add is this collision detection. Now, this is a little tricky, and I gotta tell you, it's even a little tricky for me just to kind of read to begin with to say, oh yeah, that's what collision means.
Yeah.
But this is the formula here. We're talking about. It says basically, if you think about, let's think about the X and Y position, like as in the bottom, I think the bottom left-hand corner of the rectangle, okay? And it's basically saying, hey, if the bottom left-hand corner of the rectangle is less than, oh, wait a second. So I bet you that X and Y, let's go find out about these rectangles, because this math's not making sense if it's bottom left-hand corner to me. It looks like the X and Y have to be the top right-hand corner of the rectangle, but let's find out for sure. We're going to go over here to Java Doc. Okay, let's read a little bit more about these rectangles here. Sometimes the document is so good they'll actually have pictures, and they'll show you the relationships of things. But I don't see it in this case. But let's go up here and take a look at it. We know what a rectangle is, and it looks like the height and width, the X and Y. Now the let's move this. Oops. Let's move this like this so we can kind of see our math a little bit while we're doing this, okay? Like right here. Can you see that?
Yes.
Okay. So let's take a look here. So when we define a rectangle, see this rectangle right here?
Yeah.
Okay. We define it with the values that are defined in the class here. See this x1, y1, whatever, that kind of thing, okay?
Yep.
Okay. But what we're wanting to do is basically decide what the x rectangle dot x field is. Well, if you look at the rectangle dot, oh, this is the Java frame documentation. I'll close that. If you look at this, the x coordinate is the upper left-hand corner of the rectangle.
Okay.
And the y coordinate is the upper left corner of the rectangle. Okay?
Okay.
So that kind of clears that up. So what I want to do is, let me see about getting like a, what I want to do here is I will draw this little rectangle here. Just so I can point at it with you. Oh, look at that. Automatically spaced a whole bunch of stuff I didn't care about.
Huh.
Okay, let's see. Okay. Oh. Okay, so it's basically, I'm going to highlight this one. See, this is the upper left-hand corner, that little highlighted thing?
Yeah.
So it's saying if this location is less than the other rectangles plus the width. So let's think about this. Let's put this rectangle let's see. Oh, the tabs I guess don't work there. Okay. say we have these two rectangles in this spot here. Okay, so this will be, let's call this one, this rectangle, we're going to call this one R1. Okay. We're going to call this rectangle R2. So the question is here, so it's saying this, we're gonna call this is the x spot that it's talking about. And it says if this value is less than this value plus the width. So anywhere in here, oh, plus the width. Oh, so it's saying this spot. How do I do that?
Yeah, the whole top section.
No, not the whole top, just that one, just where the $sign is.
Okay.
So this is, do you believe that X is R1.X?
Yeah.
Okay. That is R1.X because it's R1 and we know X is the top left-hand corner. XY is there, right?
Yeah.
Now R2X is right here, right?
Yeah.
Plus the width. So if you were to add the width plus this, you would end up at that $sign.
Yeah.
Okay. So it's basically, it's saying for this to be a collision, the very first criteria is that this needs to be less than this spot. Do I believe that?
Yeah.
Well, what about if this corner collides here in this spot? Like from here to here.
That's true.
Then this wouldn't be this.
Would it have to be?
Because the reason I'm doing this, because this is a bunch of ands. See this, all these ands? So all these things need to be true. All of them need to be true.
Would it have to be with R1's height too?
Well, it's basically what it does is it considers the X and the Y. Okay, here's what we're going to do. I think we might have found a flaw. I feel like I might have found a flaw in the collision algorithm. Hold on a second. Draw another scenario here. Okay, now here is a scenario where R1 and R2 collide, right?
Yeah.
Okay, R1 and R2 do collide here. And this is one scenario right here where R1X oh, excuse me. R1X is less than this. Because if you think about only the X, the value from left to right, then that is true. So the only way for, oh, I get it. Okay, if you think of it, if you put both your hands up, oh, I like this. They've got a video here, so. Oh, I know what I gotta hear. Stop sharing. Okay, so check this out. So what it's basically saying is if you have two blocks like this.
Yeah.
And then, oh, let me just put it on me here. Okay. If you have two blocks like this, the very first criteria that they're touching each other is when they first touch like this. It doesn't matter how high they are, but at least one of the conditions is they're at least next to each other, right?
Yeah.
So if you look back at the let's look back at the example here. What it's saying here is that R1X so if these are if the only time that R1X is going to be less than the dollar sign,
Yeah.
is when the dollar sign is on the left side of the X.
Okay.
Do you see that?
Yeah.
If you were to move the R2 with the dollar, this one right here, if you were to move to the left and the dollar sign was left of the X, then this first statement right here would not be true.
Okay.
So it's saying one of the criteria to determine if if there's a collision is it says the dollar sign needs to at least be on the right side of the X.
Okay, but what if it's far enough that the rectangle's not near it, but it's still on the right?
Well, I think this is where the other ones come in.
Okay.
Okay, so it's saying one of the criteria is the dollar sign cannot be left of the X.
Okay.
Let's look at the next this statement right here. The next thing that has to happen is it's saying that I'll change this to a hashtag. This is going to talk about it here. And I'm going to change this to a percent, okay? So here it's saying R1X, which is the X in there, plus the width, which is the hashtag. Okay?
Mm-hmm.
Needs to be greater than R2X, which is the percent.
Okay, yeah.
So if you only think about it moving left and right, these two things have to happen or they're not overlapping. But then you're going to have a situation here, like here, where these first two checks are going to be true. They're still not. Sounds like you're having a family reunion, huh?
Kind of actually.
Okay, now this R2, I'm going to change this to R3 for our discussion here, okay? Now, in this case, R1 and R3 meet both of these requirements, right?
Yeah.
Because the dollar sign is not left of the X, and the percent and the hashtag is greater than the percent sign. So in both these cases, the first two criteria are met, but R1 and R3 are not colliding.
Yeah.
However, if we think about up and down and doing the exact same thing, then we know it's a collision.
Okay.
You know what I'm saying?
Yeah, so do we have to define the bottom left and bottom right corners?
We would. So that's done with width and height, right?
Yeah.
So this is a little bit troubling because they both say width here, and I think because it's a square, it's been working out for us. But I really think we need to. This is where I thought I saw the defect. Okay.
Okay.
Let's see. R1Y, which is the hashtag. Oh, excuse me. R1Y, which is X. Right, because X comma Y that's the location, right?
Yeah.
So at the X, and it says if the X is less than, as long as the X is less than R2 plus width, but this is Y plus width. But the problem is if it turns out if it's a square, because if it's just as wide as it is tall, then the math will be right. And we'll have this spot right here, which we're going to be doing as a at symbol, okay? Now, normally, if you think about this, this is the formula we're looking at right here, okay? This is where the problem is. So if I say R2, which is the hash or the percent sign plus the width. Well, the width is defined this way, not this way. It should be height. But if it's a square, it happens to be the same math. But these are supposed to be for rectangles, and there's only one special rectangle that's a square, and that's when the height and the width are the same.
Okay.
Right? So let's fix this code. This really should be R2 plus height. Okay, do you see why it should be R2 plus height?
I think so. But
Okay, let's
I'll be better to explain it again.
let's change it back to width, and let's expose the problem.
Okay.
So if these were width, and okay, so let me see if I watch this. So if I were to make the rectangle 500 by 50, I think we're going to have a whole different scenario where it thinks it's intersecting. Matter of fact, it thought it was intersecting already, because that's why it's blue. Did it intersect?
Oh, I see. Okay, yeah.
It just didn't.
So we do height because we're dealing with rectangles and not squares, and squares have the same height and width.
Yeah, the math happened to be right, but it thought it was intersecting the entire time here.
Yeah.
Okay, because normally when it runs like this. It's red until it normally runs like this, red, and then when it detects the intersection, then it's blue. So this is not the right formula, because if it happens to be a rectangle that's wider and it assumes width, that now it's doing 500 in the calculation, and 500 is not right. See, now it thinks it's colliding the whole time. Here's the other bad thing. What if it was the other way around? And I can do 500 this way, it'll be collided and it won't even know it. See how it's red? And it's going to continue to collide. Watch this. It'll collide but not turn.
Yeah.
Oh, it did there in that case. We'd have to look at the math. Because one direction works and the other one doesn't, actually. Okay, so really, let's go back to this. We know that 500 by 50 does not work, right?
Yeah.
Okay, because it starts out as blue. But let's see if by changing this to height, if my assumption is right here, if this will fix the whole thing. That's really what it's asking for. Now they're red. See, it's not collided. And now if you watch
there we go.
As soon as it gets up there and touches, then it'll say that it is collided. See what I'm saying?
Yeah.
But we really did fix it, and that really was a mistake. Does that make sense?
Yeah.
So these are the kind of bugs and defects and things that you kind of think about. So that actually turned out to be very helpful for us to go through the math and actually see how it was working and to understand, so that we can make sure that we have the collision right. If you were working for a gaming company and you got that wrong, you'd be in trouble. You're like, how did that guy catch a football when he was on the other side of the field? Well, there was a math problem, you know?
Yeah.
So, anyways, we got the collision right. We actually stole this formula from the web. But so that just go let you know that doesn't always work out so well. Okay, now I think that we've pretty well caught back up on this thing. And one thing that we wanted to do was to think about making a game or something like the
breakout game.
Yeah, because but here's going to be the challenge is that we're going to have lots of blocks and lots of collisions and things. Some of them move and some of them don't.
Yeah.
So what we want to do here is one thing I wanted to do was there's this probably what we want to do is we want to define one is the block and one is a ball. Okay. Well, let's just do a little basic, like a basic breakout game where we don't actually control anything. Okay. So in this case, I think what we're going to do is we're going to define the one that's at 0, 0. I think when we do it, it's the top left-hand corner. Okay. Oh yeah, we don't want this size anymore anyway. We can probably make it look a little more like a block. We can make it do like more more like 50 and 25. Okay. And to me, that'll probably look a little bit more like a, oh, let's do the other one. 50 and 25. And instead of rectangle 1, what we want to do is let's create a little circle. So I think I can just do circle. Whoops. I know with a capital I. I'm just guessing here. E1 equal a new circle, maybe, and probably a radius. 25 maybe? I'm just guessing. Probably that's not it. I think this other example I had, the bouncing ball defines a circle. Maybe it's called ellipse or something. Because a circle is a little bit limiting. Let me see, diameter, radius, bouncing ball, get width. Let's see, paint, get oval. G oval. It's probably oval. Yeah, it's oval.
Oh yeah, that's right. We had to use ovals, right?
Yeah. So is it like oval? Whoops. Oh, really? Let me go here again real quick and see how they define the oval. I could go to documentation and see that too, but fill oval, okay, where is oval? Oh, how do I get like an oval object? Let's see, Alt, Enter. Oh, there's shape circle. Oh, there is a circle class. So there's one already for circle too. Okay.
Okay.
So C1, and then we're going to say we got rid of. We're going to get rid of our. Which one are we going to get rid of here? I think I want the moving one to turn into a circle. I think that was R2.
R2, I think. The one in the bottom right corner.
Yeah, okay. So as R1 is actually the mover, and R2 is the one that's not. Okay, so we're going to put this more as like a block. And we're going to do C1, R1. So what we do is, for now, we're going to, well, we don't have a collision detection that handles a circle and a rectangle. So we're going to have to write that. That there's ones that take rectangles, but we don't have one that detects circles. So we're going to have to write that. But for now, what we want to do is just to do the animation. And let me see, how would that go? Oh, wait a second. Let me go to the Java doc because there's got to be an XY position to it. Somewhere I'm missing it. Somewhere I'm missing something easy. It's probably going to be like C1.x maybe, or C1 dot. Oh, I don't know. Okay, let's go find it. So Java doc. Does not want to show me. Java doc for circle. Oh, here we go. Set the center. Okay, so it's going to be set center, set. Okay, so in this case, it's going to be C1.set center. Oh my goodness, it doesn't even show up there. That. Oh, set center X. Okay, and we're going to do it as X1. And we're going to say C1 dot set center Y. We're going to do this as Y1. And we're going to comment out this rectangle. And we're going to run this and see if we can get away with it. Nope. Let's see, what are we at here? Oh yeah, we got to check. We got a collision detection issue. So I'm going to, we're just going to leave the rectangle in for now. That probably was enough to just see. Let's see if we might have a rectangle and a circle running around there. Well, oh yeah, it's probably, I mean, probably what I need to do is do C1 dot set color. How do you do set color? G dot set color red. G. Oh. Fill rect. Oh. Where's the G? G. Oh, G. I see. Well, how does it know which one is the rectangle? That's a little strange. Oh, that's the rectangle for that. Let me see. G dot set color blue. I'm a little confused here.
Wait, so what's wrong right now?
So what's wrong right now is, so I'm seeing where I set the rectangle, but I see this G reference here.
Uh-huh.
And it comes in just as a graphic element. So, but how does it know? So this G is referring to the background.
Yeah.
Which I kind of get. But then all of a sudden it's setting the color for the rectangle. How
Well,
is
blue's
that?
when that's when it collides.
Oh, you switch it to the rectangle to set it the color.
So isn't that saying if collision detected, then we set color to blue?
Yes, it is. I'm trying to see where the set the color thing is for the let's see where the, here it is right here. Super paint G, which I don't know what that's about. Oh, and then fill it. Okay. I can get away with this one here. And then fill the oval. Why would it not be, why could I not just say fill oval with whatever it's defined as? Huh. Okay, well, let me do this then. I think I got the radius of 25. Oh, this is fill oval, not center, circle. How do I do fill circle? Maybe I kind of put a little more fun you could do for circle here. Let's see here. Let's search for fill. Set fill. And a paint value. Well, let's see if I can just do that then. C1 dot set fill paint value color dot magenta. I don't like that. Oh, that can't be converted to paint. Ah. Okay, let's just stick with the ovals. Apparently the circles play a little different game than the ovals.
That's weird.
It is weird. Where's my oval definition here? I know oval's defined here. You do not need to define oval? That makes no sense either. Maybe it's like a built-in little operator thing. Okay, so maybe let's get rid of our circle. We have a radius of 25. We have a y radius of 25. Diameter of, oh, I'm sorry. Radius, x radius. Why would you do diameter? That's not how that works. You usually do an x and y location. So likely what this is I better get the definition here, because usually an oval is defined as x, y, and then an x diameter and a y diameter.
Yeah.
Got radiuses and diameters in here. I don't know what that is. So that is probably not so good here. Let's see what it really does. So see, it's really supposed to be x and y. I don't know why they did that.
So it doesn't need the diameter in there?
No, this is really x. This is really y. I dealt with the code was coming in so badly. And then if you set the on an oval, if you set the x diameter and y diameter the same, that's a circle. And then let's see here. So I filled it. Let's see what happens if I get enough to where it even shows up. No, it doesn't. Okay, so we have the oval, and then what we do is well, one thing we need to do here is we needed to bring this down into an area where I can execute it. We need to put it down in, we're going to do it right here. That makes the most sense. So there's setting a color, and we're going to do something that really stand out. Okay, and then as for paint, I see. And let me see, how am I going to do this? Let me see, I don't want to cover on top of it, so I'm going to say -20. I'm moving the circle away from the square because it's currently moving a square around. So I think that's.
Oh, okay.
Okay. Oh, look at that! I did some kind of crazy math there. But there's my little magenta circle. You probably see that, right?
Yeah, I see it.
So I must have a totally different coordinate system than the squares, because my x1 and y1. Oh, x2, y2. That's why it was x2, y1 on y1. Now it'll start. Now it'll move with the before my red rectangle was covering my. Okay, so normally, and if my magenta ball here now collides with that brick, we wanted to be able to do something. Okay.
Yeah.
Now, one thing we're going to do at this point is we're going to not have that brick move, and we're going to set it at a fixed location. Okay, kind of still playing with it, debugging. Okay, that probably wasn't a good spot. So like a 50, 50, 50. Okay, move it to where it's actually not collided first. Okay, so it's not collided there, and it's still going to determine if it's collided or not, because whether it moves or not has nothing to do with the math.
Yeah.
Can get there. See, now this time what we're going to do is, instead of offsetting it, we are not going to print the let's see here, fill rect. So we are not going to fill oh, that's for the background. If we get rid of this, I think we get rid of that other rectangle. Okay. It's still moving in the background, being dry thing, but it's
Yeah.
not.
Wait, so
And you also,
why isn't the green rectangle moving?
because we got rid of the. Oh, it didn't do a collision because it's not drawing it. Okay. Why is the green not moving? The green's not moving because we commented these two lines out,
Oh, okay.
and we want it to look more like a brick.
Yeah. Oh, yeah. Because in Breakout they don't move.
Yeah. And so now that we know that our thing is not going to cover over the ball, right? Then we can actually draw this thing, and the ball would actually literally come up here and potentially hit this brick. Okay.
Yeah.
At the point that it does the brick. But the problem is the reason it doesn't know if it detects it is because we don't have any collision detection for these two events. Okay.
Yeah.
Are you starting to see how we're going to go about this?
Yeah. It's
And
kind of
once you
painting a picture in my head now.
once you build one brick and one collision kind of thing, then you can just duplicate your effort and put the bricks in different spot and get it to where it'll work for all of them. It is going to be that you're going to set the visibility on those bricks to false when they're hit.
Okay.
And you will want to change the direction of the ball.
Yeah.
Right? Now, let me take a look and I'll show you this bouncing ball example. It's the same ball, but look what happens when it gets to the edge of the J frame.
Yeah, it changes direction.
It changes directions. Okay. So we're going to use a very similar math pattern as this. This is going to bounce around and it is going to basically have the same kind of physics. Now, here's the other thing is we also, if you can imagine a line down in this about this area, you see where I'm moving my mouse?
Yeah.
A line about this high off the thing. If the ball gets below that line, then you lose a life. Why is that? Because normally you would control a paddle that moves back and forth and it needs to collide with the moving paddle.
Yeah, so we say if it hits that line, then the game ends.
If it hits that line, then it just changes direction, goes up. If this ball collides with this rectangle in, oh, I can't even do it. But imagine a rectangle that's defined all the way down here. It's just below the paddle.
Yeah.
Okay. If this ball collides with that rectangle down there, then you lose a life when you start over.
Okay.
You get the idea?
Yeah.
These things are actually kind of simple when you unravel what's really happening under the hood.
Yeah.
This game right here was first introduced when I was a child. Not this one, really. It was even simpler. It was called Pong. I kid you not. Here you go.
Yep. One of the first video games, or is this considered the first video game?
It was the very first home console video game. Two paddles. You had these two paddles and you played human against human.
Yep.
It was that you had to move the paddle to make contact with the ball. It was like I don't know, hockey or something. And they had different modes where the paddles can be bigger or smaller. This was a hard mode here.
So would you play this like on the same computer, just with like different keys?
Yeah, or you can use the mouse or whatever.
Okay.
Okay. The history of this game. Okay. Oh, I said it came out in 1972. Okay.
Yeah.
This game was, for its day, this was incredible.
Yeah.
Because it was the first time that, the first concept of two people sitting down and playing a video game.
Yeah.
Okay. You could probably make that game now. Okay. Here's the Wikipedia history of Pong. Let's see. I want to see how much Pong made. Let's see. Okay, they're talking about just a Pong arcade game, made about $10 a day, and then it started taking in about $40 a day. People were standing there playing Pong. I want to know what the so I think did Atari own this? I think Atari bought the rights to Pong. The bucks over its okay. There's kind of like a Pong console. I don't remember this one actually. This was there was all kinds of companies coming out with this because Atari was not the first. It was made by a company called ColecoVision, or who made Pong? I don't know. Oh, the Odyssey console. Basically, what I'm saying is this game made millions of dollars, and you have the ability to generate this thing in a couple of weeks.
Yeah, that's pretty awesome.
It's pretty awesome. Now, of course, a game like that would not compete today. However, if you look at Minecraft, you would start to wonder again. Because it's not exactly the best graphics in the world, you know?
Pretty simple stuff.
Pretty simple stuff, but it has a lot to do with the play. Okay, so what I'm trying to do with this story and stuff is to show you the potential that you have and to give you a little bit of motivation as to how far you could take this thing.
Yeah.
Do you draw or do any kind of artwork?
No, not really.
Well, for those that don't, when you see a drawing and stuff like that, somebody has spent hours doing that. Normally, the stuff that you see that you really appreciate that's done pretty well takes hours of work. The detailed stuff, the realistic stuff. And you keep working at it until it works in the way. Then you develop a video game in the same way. Like you start with these basic fundamental blocks, building blocks, and you just keep building on them until you've got the thing that you're wanting.
Yeah.
So it's it's a little artsy, in a way that you basically have a virtual canvas that you can do whatever you want.
Yeah.
All you have to have is the writer. Yeah. I did show you this other game that I was so addicted to back in the 386 days, right? This Star Explorer thing. This game literally looked just like this. Okay. It was running on a 386, and the guy I have the guy moving to the left and right arrows right now, but normally he would go ticka 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 ticka, and his little legs would move. And then you would go up and down, you enter these doors, and then you would get to these different screens with this level of quality of graphics. Made huge money on this game, and but it was just so fun to play because and really, I bet you that I could come up with it. It doesn't have to be much better graphics than this, and I bet you can make money at it, especially with the craze with like Minecraft, if the play was fun. Because it really, I think the Minecraft proves that if it's fun to play, it doesn't really matter about the graphics.
Yeah, it's pretty true.
Right? Yeah, it's kind of true. Anyways, I just wanted to give a little bit of inspiring thing. So, anyways, this little bouncing ball is our ball in this game, and this collision and thing right here is our first breakout block.
Yep.
But right now the ball moves, and it hits it, but we don't recognize the collision. Now, it does turn out that there is collision detection in the bouncy ball thing, but what they do is they check for the edge of the frame. We have a different kind of thing about collision. So we're going to have to kind of figure out what the best way to do the collision in this routine is. And I think what we need to do is we need to make another method right here that basically, instead of taking a rectangle, it takes a oval. It takes an oval, right? And I'm not using oval. Yeah, it takes an oval.
Yeah. Would it change the
Uh-oh.
R1?
Let me see. And wait, it says create a class oval. Uh-oh, where's oval defined? I have to have a type oval. Oh, there's oval. So oval is defined in the what class? I got to go back up here. Oval is defined in a, in a graphics class. So it's a graphics class. I wonder if I have to do that now. This could be a little trickier. Okay, so if I have a graphics, I wonder if I can do R1. What do I have access to? Yeah, now what I really want though is I want information about the oval, and I'm not going to get it. So oval may not have been the best way to go.
Just draw oval, but I guess we
I
don't
see
need
draw
that.
oval, but I really want information. I want to be able to ask, where are you at, oval? You know, like what's your X and Y mode? What's your thing? So I think we really should get a shape class that's already defined and not use oval. I really want to get like a, I guess if there is a circle, I'll take it. Okay, I'm going to define this circle. It seems to be happy with this circle. And then the circle, what I'm going to do here, instead of that, I'm going to say, and is there a fill? Let me see if there's not a fill rect, it's a fill. Can I do that? Fill oval? Is this really gonna let me, is it consider the circle to be an oval? I'm gonna have to check real quick here.
That wouldn't make sense.
It's a special kind of oval. But I'm wondering if this will then, no, it doesn't like it. Oh, it doesn't like it because it's down here. Oh yeah, let's get rid of this method that we haven't even defined yet anyways. It did seem to do that, didn't it? But I'm not sure it's playing with this. Fill rect. Oh. I don't know. I got to think about this. So I'm not sure we actually have the oval and the. I do think we have an oval, but I don't think it's associated with this circle. We're not
Okay.
even using this circle, and I'm wondering what is the significance here. We have collision detection. I get that. This is a little tricky. I'm not quite getting that. Why is it doing that? So if filling a rectangle with. Is there a G dot? Let's see. It's got to be a G dot fill something. But let's see what this is doing. Yeah, it just does. It does take it. What is this? Ooh, look at this. Draw 3D rec. Do we have access to it that easy? Oh, is it really this easy? Not a very interesting looking 3D rec, but it is a 3D rec. It's got a shadow and everything. Let's see. Let's see what other 3D stuff we got access to here since we just did it. Oh, raised. Yeah, it is raised. It's not raised very high. It's a rounded wreck. Well, okay, well, we'll have to investigate what it's going to take here. It looks like the fill rect is what we had here before. Okay, and for some reason it recognized that R1 as the rectangle. Yet when we said fill oval, it did not recognize this as, oh, C1 dot get center X? I don't know. No, that's not it. C1 dot, does it have a X property? That's the reason. Huh. Okay, well, we'll have to investigate that. There's setting and stuff, but what I want to do is be able to use a circle so that later I have a reference to it for detecting collision.
Yeah.
See, the reason is because this R1 here and R2, we have a hook to our rectangle. Well, I need to be able to have a hook to the circle, the ability to determine collision for a circle. Oh, actually, since they're doing it with the bouncing ball, let's see how they're doing it. They're doing it with oval, which is fine. Okay, so fill oval, but how do they determine if it's a collision or not? Right here. Oh, it's just get width. Wow, there's a lot of implied there. Boy, there sure is a lot of implied calls. That's only one. That's only one object. So I'm going to say like what? Oops. I do C1 dot get width. No, what did they call? Oh, that was not a circle. That was an oval. That's why they can call that one. There is no, maybe it's get radius. What let me see, what else, what are the gets that I have there? Oh. Get radius. That's good. Should be okay though. Oh, from a double to an int. Well, how about that? Oh, because the oval can't be fractional. Well, we'll have to work this out. It might be a good kind of homework thing to kind of figure out how to get access to a circle and then do collision detection. So yeah. Basically, we're going to have collision detection for rectangles. That's for two rectangles. Collision detection for a oval to a rectangle. collision detection for a paddle, which is another rectangle, right?
Yeah.
And a circle. And so basically we only need to have a collision for a ball and a rectangle.
Okay, so
Because
is the collision for rectangles like with the ball and the rectangles? It's not like rectangles and rectangles, right?
right. So in our game, it's not going to be rectangles. It's going to be a rectangle and a ball.
Okay. I was just making sure that's what you meant.
Yeah. Now, the other thing it needs to do is not only does it need to detect the collision of a rectangle and a ball, it really needs to check the collision of the ball and a list of rectangles. So it's
Yeah.
basically going to look for all the rectangles on the entire page and look for a collision.
Yeah, so like rectangle 1
The
and 2 and
collision,
3.
then it needs to return back not only that it did collide, but it also needs to return back what rectangle it collided with.
Yeah.
Because then we need to set the property to false and so that it disappears and so that it also knows there's collide. So there's a little bit more to it.
So to make the paddle, could we just make it the paddle like itself just like rectangle 1 and then
Yeah, it could
say
be.
if the ball hits rectangle 1, it doesn't disappear and it, you know,
That's right. It's
shoots
a
off at
special
a 45
rectangle.
angle.
You can call it paddle.
Yeah.
And if
And
it collides with paddle, then paddle doesn't disappear. But it does have a collision detection.
And then we use JPanel to put keys to control that rectangle, right?
Yeah, and then we got to put in the key events so they can detect the left and right arrow. And as you go, you got to make sure that the paddle doesn't move past the side of the J-frame, can't move any further to the right or any further to the left.
Oh, that's true. Huh. Didn't think about that.
So I think a lot of these examples you could probably get on the web and get started. But do you think you can start a project and see if you can get something done that we hadn't solved yet?
Well,
Like,
so I'm thinking I might be able to, but I have looked up a few videos on how to do breakout game, and I have a little bit done already, but
oh,
it's
you
not
do?
really from me. A little
Well,
bit, yeah.
let's see what you got, and at least let's see if we can understand the code. So why don't you
Okay, so
share?
I'm doing screen share now.
Yeah.
Okay, so can you see my screen? Okay. Sorry about that.
That's okay.
Here we go.
Yeah, I see.
Okay, so we have game. Okay, so the guy has map generator, which I didn't get past that. Then we have this part. So we said
So you have errors. It does not run.
what? Oh, I have
Run?
not run it yet. I had it to where I could make the application. So like
It
the
doesn't look
box.
like it will run because of gameplay. The
Yeah,
gameplay's got errors. Let's open it
the
up and
gameplay
see.
has errors.
Let's go
So
down to the first error.
here we have the timer. There's a few things.
Okay, but what about why is timer? So put the word timer in front of it.
It says
Capital T. Say timer, small timer. Capital timer, and then space small timer.
oh, okay,
No,
like that.
yeah, timer. And then the other timer is like the little t. Timer.start is little t. No, that was right.
Okay, I see what you mean.
The timer.start is little t. So that probably will fix that.
Okay, there we go.
And then graphics, what you do is paint graphics. Why wouldn't it not know graphics? But go ahead and do the
Alt enter.
the little, yeah, they import it. Yes, graphics. That'll do it. First one.
There we go. And
Okay,
then
and then color, do capital C.
okay.
Okay, well, put highlight over it. Wait, hold on a second. No. No, that's not right. Let me take a look here. It is color, capital C, color dot. Why is that not the way? Oh, get rid of the word black and dot.
Okay.
Yeah, get rid of dot.
Oh.
and then hit dot after color.
Like that? Oh, here we go.
And then choose like blue or something, black or whatever.
Oh,
Okay.
it's because this
And,
word has to be capitalized, right?
well, yeah, that's true too. But and then the set callout, set color.
So why do these not
See,
have to be
the first
capitalized?
error.
Oh, set.
It's yeah, callout to color. And then the fill g dot fill rect. What is it complaining about?
Oh, maybe it's this comma here.
Oh yeah, it needs to be missing a comma. And well, because it understands both, that's why. So now it probably will run.
Okay, let's try this.
See if it clicks on. See if it runs. Don't like it.
Did not work.
No, it didn't. Let's see what incompatible source code, erroneous types, record gameplay. Let's see. Well, we didn't do anything in particular, and there's no collision detection, so that's not so good. Is there any collision detection?
So
let's take a look at main here.
No.
Let's see what they've done.
Right here?
Yeah, so there's set object bounds, resizable, default, obj.gameplay. What's gameplay? Gameplay, let's look at gameplay. Gameplay is where it's all
This
all
is
happening.
gameplay.
That's it? Oh, that's not enough. Oh yeah, there's more. Okay, good.
Yeah.
Oh, there's some key pressed events we might have been able to. Let's see. Okay, go on up. Got a lot of unsupported there. So there's the drawing gameplay. He's not really doing much, really.
Yeah.
So I don't know if this really works.
Yeah, I didn't get through all of it. I just tried to write some of it for now.
Uh-huh. You can get rid of the duplicate of the scene paint colors. You got 3 of those in a row.
Oh.
You can get rid of 2 of them. It even says there what you don't need it or what. Yeah, remove it. It's totally unused. Why is it G-panel? Yeah, import, there you go.
Huh.
Okay, so you'd have to go through the code. It doesn't look like it's too impressive. However, if you see that on the gameplay there, you got whether or not you're in play mode or not. It keeps track of a score. It says there's a total number of bricks. There's a timer, a delay. Okay, now let's see what happens in gameplay. So let's go down to gameplay. No, down just a little lower. There you go. It says add a key listener. Yeah. No, up to gameplay. There, gameplay. Right there.
Yeah, here.
Add a gameplay. So it adds a key listener, sets the focus enabled timer dot start. But gameplay doesn't actually do any drawing, but that's okay because paint does. So paint fills some rectangles. And it actually should if you run this right now, actually it should draw some rectangles.
I'll try running it again.
Yeah. Okay, what is it saying here? NetBeans Executor. What? Let's see. Click on the main Java 11. Yeah, click on that. And what is it saying here? Exception. There's an exception.
Highlighted this.
Yeah, it says uncompilable source code of brickbreaker dot. Oh, brickbreaker. Click on gameplay again. Oh, you don't have any namespace set up or anything. Go to the very top of this file.
Okay. Brickbreaker?
Oh, package brickbreaker. Wait a second. There you go. Stop there now. No, that's good. Erroneous tree type. Oh, well, uncapitalize those B's in the brick breaker. Because I
Up
think
here
that,
on the package.
yeah. I think that had to match. Go to the other ones too. Actually, undo that. Undo those, and then right mouse button click on it, double click on it, right mouse button click and say rename.
Right here?
Yeah, right now, right mouse button click. Yeah. And say, if you can say rename. Is there a rename option here? No.
No.
Go to the brick breaker class over to the left hand side.
Over here?
Yeah, down though, where the package right there. Right mouse button click and say rename. Refactor. Rename.
Here we go.
Yeah. Do as capital brick capital breaker.
Wait, so capital B's?
Capital B's, yeah. Oh, okay, so it doesn't matter about case, I guess. So I say cancel. I guess it doesn't matter about the case sensitivity of packages,
Well,
which is interesting.
is it because it says... Oh, never mind, I see.
Yeah, just doesn't care. Okay, let's see here. Erroneous tree type, what would that be? Let's see what erroneous tree type means. I'll just do a search. Let's see, what does that mean? Let's see. Not a good, let's take a look at the gameplay. Gameplay, okay, go to the top. It does have a constructor. I'm searching, I don't know. Sometimes when you bring in other people's codes and you try to merge it in, you get situations which are never meant to be found.
Yeah.
I don't know what they're trying to say. Well, so let's see about doing, click on the build, that little hammer.
Which hammer?
Oh, the little hammer next to, that one, yeah. Click on that,
One.
see what happens, yeah. Clean and build.
Oh, whoa.
Okay. So there's really the problem. So go ahead and go down. Click on the first error, the 11, Java 11. Let's see,
Wait,
click on the, yeah, that first blue one. Down in the list.
Oh, this one?
Yeah, click on that one. Cannot find the symbol gameplay. So you probably means that you need to do, what is wrong with gameplay? It can't find it. I thought it was all part of the same. So do an import on that. See if you can do a, no, you shouldn't be able to do. So go to the top there where it says import and see if for some reason it needs to be imported. So on line 4.
Oh yeah.
Type import. space G, capital G, a game. I'm just wanting to see if I can. I didn't think that was going to work, but I just want to see if it would find something. No, go ahead and get rid of it. Let's see. Oh, let's see if maybe gameplay is not in the same package. So go ahead and do. Oh, yes, of course it is because it's there. What's wrong with this gameplay? Oh, click on gameplay. Actually, no, the class.
Oh.
Yeah. Going down. No, it doesn't take any parameters. Public gameplay. Why is this a problem?
Could it be something with this public class gameplay extends JPanel?
No, because you have the constructor. Oh, implements. No, that's not bad. Okay, go back to main. Just on a line in there, in the main, just type somewhere else. Type gameplay. I'm just kind of curious if it's either no inside the public static void main.
Oh.
And then hit enter. Yeah. Type gameplay. It really doesn't. G. I guess hit G.
G.
It really does not. It does not see gameplay, does it? Yeah, it does actually. Gameplay G equals new. Gameplay. It really does not see it. And do the open and close parenthesis. Okay, then right below that, hit enter. Hit G dot. Nope, it just does not see it. What is the deal? Is it because, let me see here. Cannot find the simple gameplay. Cannot find gameplay.
What does it mean down here when it says cannot find symbol?
It means it cannot find a reference to that.
Oh, okay. Huh.
It's somehow, it can't see it. So you can get rid of that line 10. Let's see here. But there's got to be something simple to this. Is there a, do you know where the sample was on the web?
I found it on YouTube somewhere. It's just for Brick Breaker game.
Yeah. Well, you typed it in?
Yes. I don't know if I can find it again, but.
Well, if you had to type it in, then let me see here. I wonder why it liked what you typed, though, if it can't find it. What is the problem? Huh. Let me try to generate this same scenario here. In my environment, I'm going to do a new class called, and then over here in bouncing ball, works no problem for me. So here's what I want you to do. Let's do a little bit of start. Let me go back over to gameplay. There's got to be something going on with your gameplay file. Go to the very top.
Here we are.
Oh, extends JPanel implements key listener. That's no problem. So go ahead and right mouse button click on the brick breaker namespace to the left hand side. Over to the left on your your project list there. Say new class, Java class, and we're going to call it let's call it play.
Capital?
Yeah, capital P. Yeah, enter. Okay. Now let's take the stuff that's in gameplay. So double click on gameplay and click on the extends JPanel implements key listener action listener. And
right here?
Yeah, copy the extends JPanel implements key, including the extends. There you go. Control C.
Copy.
Control C.
Okay, and then
go to
down
play.
to play.
Yeah, go to play, and then click before the before that, right after the word play.
Oh,
and then paste. Okay, say okay. Okay. And now.
What's wrong with this?
Wait, oh, let me see what it says. Oh yeah, implement the abstract. Yes, first one. Okay, that's okay.
We want all that, right?
You have to. Then click on the gameplay. Okay, let me go. Just slide on down because I don't think you need to do anything else. No, you don't. Go back over to the main. And right in the first line there, say play.
Right here?
Yeah, say play. Space. M.
M?
Yeah, I'm sure. Space. Equals new play. All capital play there. With the capital P. Wonder why it has a problem with this. Okay, now that's good. But it's italicized like the same problem. Compile that and see if it has a problem with that one.
Okay.
Yeah, just compile it.
Wait, how do you compile again?
Hit the hammer.
Oh.
I want to see if it complains about that line. Go on up in the errors. On the bottom.
Right here.
Yeah, I cannot find a symbol.
Complained about it.
Public static void. Is that where your problem is? Let me see. Arg. This is crazy. Oh. Yeah, I don't think you can make a method called main class. You change maybe rename the word main. Say refactor.
Refactor.
Rename and call it game or something. Yeah, just call it game. Enter refactor. I think that might be a reserved situation. And it doesn't seem to fix that. So click on that little hammer again. No, it doesn't like that. That's crazy. Do you have to have that Java X Swing import?
Right here?
Yeah, try commenting that out and see what happens. That's for a JFrame, okay. So undo that. Where is the problem? You almost have to start a new project. You did start a new project when you did this, huh?
Yeah.
The problem is that it's not making, the error is not making sense, and I don't know what the deal is. And unfortunately, it's going to be very easy when we figure it out.
Yeah.
Let's see here. Yeah, it's going to be very easy. Well, it's pretty darn close. This would be a good thing for you to figure out why it's not, because it's getting pretty close.
Yeah.
You can, I'd leave it renamed as game. You can get rid of the word play. So you can click on the play a job right mouse button, click say delete or whatever. Yeah, delete. That was not it.
Okay. Yeah, I guess I'll just try and figure it out sometime.
Yeah, look at the errors, see if you can type in the errors and get ideas from on the
Yeah.
web as to what the thing is, and see if you can report that back.
So do you think I could rename this as main and it wouldn't be a problem in the future?
Yeah, that's not a problem now, I guess.
Okay.
So you can refactor that and call it main. And do refactor. Because the problem would have went away if we would have fixed it, right? So
Yeah.
in that situation, yeah. Yeah, get rid of the word play because obviously that doesn't exist anymore. Line 10.
Oh, line 10.
No, 10.
Yeah.
That's why it's complaining there. That one was easy. It's the gameplay that we don't understand. It just says it doesn't find it, so it's some kind of a reference problem, and I'm not sure.
Yeah. Okay, so what are these yellow problems again?
It looks like yeah, what it wants, it's a warning, or it's sometimes it's just info or suggestion. It's basically the paint operation has been overridden, which means that you're using your definition and not the built-in.
Okay.
So and it wants you to put an annotation there that says this is a warrant. This has been overridden. That's not that necessary.
Yeah.
Let me see. Oh, let me see something a second. Let's go down on the gameplay. I don't know why it's red. Click on the build thing, see if it makes the red go away. Yeah, clean and build there again.
Stays.
Yeah. Okay, so go to the gameplay. There you go. So we've got this. Okay, so let's do a couple of things in here.
Okay.
Let's in the gameplay, let's comment out some of the stuff that's in the constructor.
In here?
No, the constructor. So that would be the gameplay constructor. Matter of fact, just comment out. So highlight the whole constructor. The whole thing. Got to do the other one too. The other down.
Oh.
And I think you can do. Then what can you do? Hit the what is it? Source. Choose source.
In here?
Or comment. What is it? Oh my goodness. What is it? No. There's a source at the top.
Oh, up here?
Yeah. Choose source. And then I think there's a comment code. I think why don't you just try control right /. Oh, there. Wait, remove surrounding code, fix code, toggle comments. Yeah, toggle comment. That's it. Toggle comment.
Oh, toggle comment. Okay.
Yeah, there you go. Okay, now try running it and see if it compiles. No, it doesn't like that.
Huh. So do you want to just go back?
Yeah, I'm not sure what the Control Z. I'd have to just look. Okay, well anyways, we're gonna wrap it up for the evening.
Okay.
Stop sharing. And anyways, we'll continue. We'll try to do something interesting with it. And but the idea is to